Chapter 3 Factors and Multiples. Recall the table of 3. What do we get when we multiply 3 with 1, 2, 3 and so on? What do we call them? Consider the number 18. In how many ways can we multiply 2 or more numbers to get 18? Factors. Ria wants to plant 8 saplings in equal groups. How many different equal groups can she make? To make different equal groups, let us write the factors of 8. 1 into 8, 8 groups of 1 sapling each. 2 into 4, 4 groups of 2 saplings each. 4 into 2, 2 groups of 4 saplings each. Numbers that multiply to give a product are called factors of the product. Any number has only a limited number of factors. Example 1. Write all the factors of 12. 1 into 12 is equal to 12. 2 into 6 is equal to 12. And 3 into 4 is equal to 12. Answer. The factors of 12 in increasing order are 1, 2, 3, 4, 6, 12. Properties of factors. Every number has at least 2 factors, 1 and the number itself. 1 is the smallest factor of every number. The number itself is the greatest factor of itself. A factor of a number is smaller than or equal to the number. A factor divides the number completely. To check if a given number is a factor of another number, we divide the second number by the first. We can also use tables or divisibility rules to check for division without performing division. Example 2. Check if 5 is a factor of 40. To find the above, we check if 5 completely divides 40. Answer. 5 completely divides 40, so 5 is a factor of 40. Divisibility rules. The teacher asked Rimjim to place 225 color pencils equally in 3 boxes. Can she place the pencils equally? Problem solving. Placing equally means division. Divide 225 by 3. Is 225 completely divisible by 3? Use divisibility rule of 3. Divisibility rules help us to find if a given number is divisible completely by smaller numbers without actual division. These rules help in estimation and make operations of numbers easier. Multiples. Multiples of a number are numbers obtained by multiplying the given number with non-zero numbers like 1, 2, 3, 4, 5, 6 and so on. Since non-zero numbers are unlimited, the multiples of a number are also unlimited. Example 3. Find the first 5 multiples of 6. 6 into 1 is equal to 6. 6 into 2 is equal to 12. 6 into 3 is equal to 18. 6 into 3 is equal to 18. 6 into 4 is equal to 24. 6 into 5 is equal to 30. Answer. The first 5 multiples of 6 are 6, 12, 18, 24, 30. Example 4. Write any 5 multiples of 7, recalling the table of 7. Answer. Any 5 multiples of 7 are 14, 35, 56, 63, 70. Example 5. Write the first 2 common multiples of 2 and 3. Multiples of 2 is equal to 2, 4, 6, 8, 10, 12, 14, 16, 18. Multiples of 3 is equal to 3, 6, 9, 12, 15, 18. Answer. First 2 common multiples of 2 and 3 are 6, 12 and 18. Multiples of 2 are even numbers. Numbers which are not multiples of 2 are odd. Properties of multiples. Every number has 1 and itself as a multiple. The first multiple of a number is the number itself. Every multiple of a number is equal or greater than itself. Every number has infinite multiples. Divisibility rules for 2, 3, 5, 9 and 10. Divisibility rule for 2. If a number is even, ends with 0, 2, 4, 6, 8, it is divisible by 2. Divisibility rule for 3. If sum of digits of number is a multiple of 3, it is divisible by 3. Divisibility rule for 5. If a number ends with 0 or 5, it is divisible by 5. Divisibility rule for 9. If sum of digits of a number is 9, it is divisible by 9. Divisibility rule for 10. If a number ends in 0, it is divisible by 10. Help Rimjim in placing 225 pencils equally in 3 boxes. Check if 225 is completely divisible by 3 by using divisibility rule for 3. Apply divisibility rule for 3. If sum of digits of number is a multiple of 3, it is divisible by 3. 225. 2 plus 2 plus 5 is equal to 4 plus 5 is equal to 9. 9 is divisible by 3. Hence, 225 is divisible by 3. So, Rimjim can place 225 pencils equally in 3 boxes. Example 6. Answer the following using divisibility rules. A. Which of the numbers are divisible by 2? 31, 48, 206 and 500. B. Find if 5618 is divisible by 3. Answer. A. 48 and 500 are the numbers divisible by 2 as they end with an even number. B. 5618. 5 plus 6 plus 1 plus 8 is equal to 11 plus 0 is equal to 20. 20 is not divisible by 3. Maths in story. Can a farmer plant 801 saplings equally in 9 rows? Example 7. Which numbers are divisible by 5? Also, find the numbers divisible by 10 in them. 20, 45, 92, 105, 387, 670. Answer. 20, 45, 105, 670 are the numbers divisible by 5 as they end with either 5 or 0. 20 and 670 are the numbers that end in 0. Hence, they are divisible by 10. Divisibility rules for 4, 6, 8 and 11. Divisibility by 4. If the number formed by its last 2 digits is divisible by 4, then the whole number is divisible by 4. For example, 3216, 5748. Divisibility by 6. If the sum of digits of a number is divisible by 2 and 3 both, then the number is divisible by 6. For example, 5472, 34,326. Divisibility by 8. If the number formed by its last 3 digits is divisible by 8, then the whole number is divisible by 8. For example, 32,168, 19,824. Divisibility by 11. Find the sum of the digits in the odd and even places separately. If their difference is divisible by 11, then the number is divisible by 11. For example, 61,809. Sum of digits at odd places is equal to 6 plus 8 plus 9 is equal to 23. Sum of digits at even places is equal to 1 plus 0 is equal to 1. Difference is equal to 23 minus 1 is equal to 22, which is divisible by 11. So, 61,809 is divisible by 11. Prime numbers and composite numbers. Look at the numbers and their factors given below. Number 1, factors 1, number of factors 1. Number 2, factors 1, 2, number of factors 2. Number 4, factors 1, 2, 4, number of factors 3. Number 6, factors 1, 2, 3, 6, number of factors 4. Number 10, factors 1, 2, 5, 10, number of factors 4. Number 19, factors 1, 2, 3, 6, 9, 18. Number of factors 6. 1 is the only number which has one factor. Other numbers are 2 or more factors. 2 is the smallest prime number. It is also the only even prime number. Numbers with only 2 factors, namely 1 and the number itself, are called prime numbers. 1 is considered neither prime nor composite. Some such numbers are 2, 3, 5, 7, 11, 13, 17, 19, 23. Prime numbers are divisible only by 1 and themselves. Numbers with more than 2 factors are called composite numbers. Some such numbers are 4, 6, 8, 9, 10, 12, 14, 15, 16, 18, 20, 21. 4 is the smallest composite number. Eratosthenes, an ancient Greek mathematician, developed a systematic method of finding prime numbers by elimination using the sieve of Eratosthenes as shown. Circled numbers are prime numbers. Crossed out numbers are composite numbers. Step 1. 1 is left as it is neither prime nor composite. Step 2. 2 is circled and its multiples are crossed out as they are composite numbers. Step 3. Similarly, 3, 5 and 7 are circled and their multiples are crossed out. Step 4. Numbers left out other than 1 are circled. How many prime numbers can you count between 1 and 100? Example 9. Using Eratosthenes' sieve, find the following. A. All prime numbers between 50 and 70. B. Any two prime numbers next to each other. Answer A. 53, 57, 59, 61 and 67. B. 2 and 3. Finding prime factors. Every composite number can be written as a product of prime numbers. This is called prime factorization. Let us find the prime factors of 8. Since 8 is an even number, we first divide it by 2. Step 1. Divide 8 by 2 and write the first two factors below in two branches. Step 2. Copy the prime factor 2 as it is in the next branch. Write factors of composite number 4 in two branches below it. We continue this process till all factors obtained are prime numbers. Prime factors of 8 is equal to 2 into 2 into 2. Factors written in any other order will also give the same prime factorization in the end. 12, 2 into 6, 2 into 2 into 3. 12, 3 into 4, 3 into 2 into 2. Example 10. Write the prime factorization of the following. A. 27, B. 45, C. 65, D. 108, E. 240. Answer A. 27. 27 is equal to 3 into 3 into 3. B. 45. 45 is equal to 3 into 3 into 5. C. 65. 65 is equal to 5 into 13. D. 108. 108 is equal to 3 into 3 into 3 into 4. E. 240. 240 is equal to 2 into 2 into 2 into 2 into 3 into 5. To find prime factors of an even number, start by dividing it by 2. For an odd number, try dividing by 3, 5 or 7 first, then by 11, 13, 17. Highest common factor. HCF. Let us try the prime factorization of any two numbers, say 24 and 30. 24 is equal to 2 into 2 into 2 into 3. Common prime factors are 2 and 3. 30 is equal to 2 into 3 into 5. Highest common factor is 2 into 3 is equal to 6. Highest common factor HCF of two or more numbers is the greatest factor of their common factor. Properties of HCF. The HCF divides each number. The HCF cannot be greater than the numbers themselves. If the smaller number is a factor of the bigger number, the smaller number is the HCF. Example, 12 and 36. 12 is a factor of 36. Hence, 12 is the HCF of 12 and 36. If HCF of two numbers is 1, they are called co-primes. Example, 12 and 17. Their only common factor is 1, hence 12 and 17 are co-primes. Consecutive numbers are always co-primes. Example, 50 and 51 are co-primes. Methods of finding HCF. Method of listing factors. Example 11. Find the HCF of 10 and 18. Factors of 10 and 18 are 10 is equal to 1, 2, 5, 10. 18 is equal to 1, 2, 3, 6, 9, 18. Common factors are 1 and 2. Answer, HCF of 10 and 18 is 2. Example 12. Find the HCF of 16, 24 and 32. Factors of 16, 24 and 32 are 16 is equal to 1, 2, 4, 8, 16. 24 is equal to 1, 2, 3, 4, 6, 8, 12, 24. 32 is equal to 1, 2, 4, 8, 16, 32. Common factors are 1, 2 and 8. Answer, HCF of 16, 24 and 32 is 8. Method of prime factorization. Example 13. Find the HCF of 20, 40 and 30 and 90. Prime factorization of 20, 40 and 90 is 20 is equal to 20 into 10 is equal to 2 into 2 into 5. 40 is equal to 2 into 20 is equal to 2 into 2 into 2 into 5. 90 is equal to 2 into 45 is equal to 2 into 5 into 9 is equal to 2 into 5 into 3 into 3. Common prime factorization is 2 into 5 is equal to 10. Answer, HCF of 20, 40 and 90 is 10. Example 14. Find the HCF of 15 and 45. Prime factorization of 15 and 45 is 15 is equal to 3 into 5. 45 is equal to 3 into 15 is equal to 3 into 3 into 5. Common prime factorization is 3 into 5 is equal to 15. Answer, HCF of 15 and 45 is 15. Method of long division. Example 15. Find the HCF of 21 and 77. Answer, we follow these steps. Step 1. Divide the bigger number by the smaller, 77 by 21. Step 2. Use the remainder as divisor and the divisor as dividend, 21 by 14. Step 3. Repeat step 2 until no further division is possible. Step 4. Last divisor is the HCF. Example 16. Find the HCF of 20, 40 and 90. Answer, we follow these steps. Step 1. Divide the biggest number by the smaller number, 90 by 40. Step 2. Use first remainder as divisor and first divisor as dividend, 40 by 10. The division is complete and the last divisor is equal to 10, which is the HCF of 90 and 40. Step 3. Now divide the smallest number by this HCF 20 by 10. Step 4. Last divisor 10 is the HCF of 20, 40 and 90. Applications of HCF. Example 17. Danny and Dia are setting up a herbal garden with length and width of 40 cm and 25 cm each. What will be the maximum length of a tape which can measure both completely? The maximum length of a tape which can measure both completely is the HCF of 40 and 25. 40 is equal to 5 into 8 is equal to 5 into 2 into 2 into 2. 25 is equal to 5 into 5. HCF of 40 and 25 is 5. Answer, the maximum length of a tape which can measure both completely is 5 cm. Example 18. Aarti has 3 jugs which contain 720 ml, 600 ml and 480 ml of herbal juice respectively. Find the maximum capacity of a cup which can measure each of these completely. The maximum capacity of a cup which can measure each of these completely is HCF of 720, 600 and 480. Answer: the maximum capacity of a cup which can measure each of these completely is 120. Lowest common multiple LCM. Let us write some multiples of any two numbers, say 3 and 5. Multiples of 3 is equal to 3, 6, 9, 12, 15, 18, 21, 24, 27, 30, 33. Multiples of 5 is equal to 5, 10, 15, 20, 25, 30, 35, 40. First two common multiples are 15 and 30. Lowest common multiple is 15. Lowest common multiple LCM of two or more numbers is the smallest of their common multiples. Properties of LCM. The LCM is divisible by each of the numbers. The LCM cannot be smaller than the numbers themselves. If the smaller number is a factor of the bigger number, the greater number is the LCM. Example: 14 and 28. 14 is a factor of 28. Hence, 28 is the LCM of 14 and 28. If LCM of two co-prime numbers is their product, example 3 and 11, their LCM is 3 into 11 is equal to 33. Methods of finding LCM. Method of prime factorization. Example 19. Find the LCM of 16 and 28 by the prime factorization. Prime factors of 16 is equal to 2 into 8 is equal to 2 into 2 into 2 into 2. Prime factors of 28 is equal to 2 into 14 is equal to 2 into 2 into 7. To find LCM, we multiply common factors with non-common factors. Common factors is equal to 2 into 2. Non-common factors is equal to 2 into 2 and 7. LCM is equal to 2 into 2 into 2 into 2 into 7 is equal to 112. Answer: the LCM of 16 and 28 is 112. Example 20. Find the LCM of 25, 50 and 75 by the prime factorization. Prime factors of 25 is equal to 5 into 5. Prime factors of 50 is equal to 2 into 5 into 5. Prime factors of 75 is equal to 3 into 5 into 5. Common factors is equal to 5 into 5. Non-common factors is equal to 2 into 3. LCM is equal to 5 into 5 into 2 into 3 is equal to 150. Answer: the LCM of 25, 50 and 75 is 150. Method of short division. Example 21. Find the LCM of 6 and 18. We follow these steps. Step 1. Write the numbers separated by a comma in the L-shaped division bracket. Keep extending the bracket below with each division. Step 2. Divide the numbers by smallest common prime number. In case one of the numbers is not divisible by that prime number, copy it in the next step as it is. Step 3. Repeat step 2 till no further division is possible. Step 4. LCM is given by product of all divisors and remainders. Answer: the LCM of 6 and 18 is 2 into 3 into 3 is equal to 18. Example 22. Find the LCM of 14, 20 and 32. Following the steps given in example 21, we get answer: the LCM of 14, 20 and 32 is 2 into 2 into 2 into 2 into 2 into 5 into 7 is equal to 2870. Example 23. Find the LCM of A 26 and 65, B 27, 54 and 63. A. LCM is equal to 13 into 2 into 5 is equal to 130. B. LCM is equal to 3 into 3 into 3 into 2 into 7 is equal to 27 into 14 is equal to 358. Answer: A. The LCM of 26 and 645 is equal to 130. B. The LCM of 27, 54 and 63 is 126. Applications of LCM. Example 24. Find the least number of pencils that can be grouped in 5, 10 or 15 in each group. The least number of pencils that can be grouped in 5, 10 or 15 in each group is equal to LCM of 5, 10 and 15. LCM is equal to 5 into 2 into 3 is equal to 5 into 6 is equal to 30. Answer: the least number of pencils that can be grouped in 5, 10 or 15 in each group is equal to 30. Example 25. Ananya, Alia and Carol started jogging on a circular track together. Ananya takes 12 minutes to complete a round. Alia takes 8 minutes and Carol takes 15 minutes. After how many minutes will they meet again? Minutes after which they will meet again is equal to LCM of 12, 8 and 15. LCM is equal to 2 into 2 into 2 into 3 into 5 is equal to 8 into 15 is equal to 120. Answer: they meet again after 120. Relationship between HCF and LCM. Let us take any two numbers, say 16 and 20. Now let us find their HCF and LCM. Also let us find the product of these numbers. HCF of 16 and 20 is equal to 4. Product of HCF and LCM is equal to 4 into 80 is equal to 320. LCM of 16 and 20 is equal to 2 into 2 into 2 into 2 into 5 is equal to 16 into 5 is equal to 80. Product of the given number is equal to 16 into 20 is equal to 320. From the above, we can derive that product of two numbers is equal to product of their HCF and LCM. Example 26. The HCF and LCM of two numbers is 5 and 150 respectively. If one number is 25, find the other number. HCF into LCM is equal to 25 into other number. 5 into 150 is equal to 25 into other number. Other number is equal to 5 into 150 by 25 is equal to 30. Answer: the other number is 30. Example 27. Find the LCM of two numbers whose HCF is 4 and product is 576. LCM is equal to product of two numbers by HCF is equal to 576 by 4 is equal to 144. Answer: the LCM of the two numbers is 144.